Hello all, welcome to Tungal online classes. Now in this session we will discuss new concept. Today's concept is optics. In the previous chapter electromagnetic waves, in that we have learned what is meant by electromagnetic wave, how the electromagnetic wave can produce. If any charge is oscillating from that point, if charge goes simple harmonic motion, that is responsible for electromagnetic waves. This electromagnetic wave can be classified into 7 categories. Out of 7 electromagnetic wave, one of the part of the light that reaches to the earth, that we are calling visible light. Then in this optics, what we are discussing? Actually, we are discussing what is behavior of the chapter, what is behavior of the optics, and what property exists by the light, that we will study in detail. That is, separately we will study what is meant by ray optics, what is meant by wave optics. Before that, let us define what is meant by light and what are the branches of the light, that we will see. See here. Initially, we will define what is meant by light. Light. See here. Light is a form of energy which causes for vision, of the sight, that we are calling light. Actually, light is a form of energy which can travel from one point to another point with the speed of 3 into 10 raised to 8 meter per second in air or vacuum. But the speed of the light can changes from medium to medium. In air, it has speed 3 into 10 raised to 8 meter per second. In some other medium like ether, like in water, like in glycerin, speed of the light is different. That we will study how the speed of the light will changes. Before that, let us define what are the branches of the optics, that we will study in detail. Initially, let us take what is meant by optics. See here, optics. Optics is a branch of physics which study about behavior and properties of the light. What behavior and what property of the light that exists, that we will study under the optics. Mainly, optics can be classified into 3 categories. One we are calling geometrical optics, physical optics, and quantum optics. See here. Branches of the optics can be classified. One we are calling geometrical optics. Second one, physical optics. And third one is quantum optics. Mainly 3 branches of optics are exist. Now, for second PU, mainly we are discussing what is meant by geometrical optics and what is meant by physical optics. See here. In this branch of optics, mainly we are studying what is meant by geometrical optics and what is meant by ray optics. Now for second PUC, geometrical optics means the branch of optics we study about rectilinear propagation of the light, that we are calling rectilinear propagation of the light. Mainly we are studying the ray optics, sub branch of the geometrical optics, that we are calling ray optics. The ray optics which deals about rectilinear propagation of the light, how the light can travel in straight line path and what property of the light can exist whenever light is going on a straight way. Along straight line path, what are property exist by the light, that we will study. Mainly, wherever light is incident, light is moving along straight line path with the speed of 3 into 10 raised to 8 meter per second, it has lot of properties. Property means light undergo reflection, light undergo refraction, light undergo diffraction. So many properties are exist. Mainly in ray optics, we are going to study what is reflection of the light and what is refraction of the light, that we will study in detail. See here, the sub branches of the optics, that we are calling ray optics. Mainly in the ray optics, we are studying what is meant by reflection of the light and what is meant by refraction of the light. Now, in first chapter, reflection of the light, in detail we will study what is meant by reflection, how reflection can be possible, what are property of the reflection of the light, in detail we will see. Shall I see here? Now, our next concept is, mainly we are going to study ray optics. In the ray optics, we will study the first chapter. The first chapter is nothing but reflection of light. See here. Next concept is reflection of the light. Reflection of light. This phenomenon we will study in detail. How reflection takes place, what is responsible for reflection of the light. We know that in ray optics, mainly we are studying about rectilinear propagation of the light. I mean, we will study geometrical optics. What a geometry exists by the light whenever light incident on some surface. See here, we said that in air or vacuum, light travels with the speed of 3 into 10 raised to 8 meter per second. But whenever light incident on well polished surface like mirror or well polished surface, the light is incident on that surface and bounce back. We know that wherever light incident on mirror, light can reflect back, I mean light can bounce back, right? Or light is incident on say some other well polished surface, that can reflect back. Here what is reflection? Reflection means the phenomenon of bouncing of light whenever light incident on some surface like mirror. This phenomenon we are calling reflection of the light. Reflection means bouncing of light whenever light incident on some surface. This phenomenon we are calling reflection of light. Shall I define reflection? In what way? Look at me. The phenomenon of bouncing of light in same medium, bouncing of light in same medium, when light incident on a surface, say mirror, this phenomena we are calling reflection of light. Simply, wherever light incident on a given surface, if light bounce back in the same medium, that we are calling reflection of light. How reflection of light that takes place, that we'll see, and what are laws of reflection of light existed by the light, that we'll see now. Look at me, students. Now I can take a plane mirror. Actually, we'll study in detail regarding the mirror. Let us take, I will take a plane mirror. See here, I can take, simply it is nothing but plane mirror. I mean mirror consists of a polished surface and silver surface. Look at me. This I can take a plane mirror. Simply. See here, this is plane mirror. Let us consider a visible light. I mean electromagnetic wave we can take, not only visible light. We know that this visible light travels with the speed of 3 into 10 raised to 8 meter per second, having the wavelength of 400 nanometer to 760 nanometer. Remember this point? Look at me. Now let us take ray of light incident on a given surface. Look at here, how it is. See here. Let us take this nothing but ray of light, this ray of light incident at this point, like this. Are you following? Let us take the ray of light incident on the surface, say at O. What is the ray of light? Let us consider AO is the ray of light. AO is the ray of light. After incident, if the ray of light bounce back in the same medium, how it is reflected? Let us take this ray of light reflected along the direction of OB. Here what happens? The ray of light incident on given surface and bounce back in the same medium. Let us take this medium is what? I can take this medium is nothing but air, or I can take vacuum. Here what happens? The ray of light incident on a given surface and bounce back in the same medium. This phenomena we are calling reflection of light. Remember this point? Look at me. Now in this case we are calling AO is nothing but incident ray. AO we are calling incident ray, and OB we are calling reflected ray. So here shall I write? The ray AO is nothing but incident ray. We are calling incident ray, and the ray OB is called as reflected ray. is called as reflected ray. Right. Now, where the reapplied is incident? Reapplied incident at O point. At O point, if we draw a perpendicular line, where the reapplied incident, look at me here. At this point, reapplied is incident. If we draw perpendicular line at the point of ray of incident, that we are calling normal. Look at me, how it is. At this point, reapplied is incident. If I take perpendicular line at the point of reapplied incident, this we are calling normal. What we are calling normal? Generally, I can take MO is nothing but normal. Are you following? Normal means the perpendicular line drawn at the point of incident ray, this we are calling normal. Though in this figure, what I can take, MO is nothing but normal drawn at the point of incident ray. Normal at the point of incident ray. At the point of incident ray. Incident ray. Incident ray. Look at me. Incident ray. Then wherever light bounces back in the same medium, reflection of the light obeys two laws. Now let us see what are laws of reflection of light. See here. Our next concept is laws of reflection of light. Laws of reflection of light. Laws of reflection of light. Reflection of light. See here. What are laws existed by during reflection of the light? That we'll see. Students, to understand the laws of reflection of light, again you will take a plane mirror. On the plane mirror, consider the ray of light is incident. Right? See here. How to take? Look at me. Again we will take, this is nothing but plane mirror. This we are calling plane mirror. Let us consider XY is the plane mirror. XY is nothing but plane mirror. On this plane mirror, consider the ray of light incident. Let us take the ray of light incident at this point. Are you following? AO is nothing but incident ray. Incident at point O, and wherever light incident on the surface, how it is reflected? This can reflected like this. This can reflected along the direction of OB. Direction of OB. What we are calling? AO is nothing but incident ray. AO we are calling incident ray. OB we are calling reflected ray. Then what is normal? Perpendicular line drawn at the point of incident. This we are calling normal. What we are calling this? Normal. Then see here. Here mainly we are defining two angle. One we are calling angle of incident and angle of reflected. Angle of incident and angle of reflection. Simply. See here. The angle between incident ray and normal. Angle between what it is? I can call this nothing but normal. MO is the normal. Angle between incident ray and normal. This we are calling angle of incident. This we are calling angle of incident. And angle between reflected ray and normal, this we are calling angle of reflection. Are you following this? Which angle is there? AOM is nothing but angle of incident. Which angle? Angle AOM is nothing but angle of incident. And angle MOB. Angle MOB is nothing but angle of reflection. Mainly, the reflection of the light obeys two laws. Let us see what is meant by first law of reflection. See here. First law of reflection. First law of reflection. What is first law of reflection? That we'll see very simple. See what is first law? Very simply you can call AOM is nothing but angle of incident. MOB we are calling angle of reflection. First law says that angle of incident equal to angle of reflection. What it is? Angle of incident equal to angle of reflection. How it is? Angle of incident equal to angle of reflection. This we are calling first law of reflection. First law. Simply angle of incident equal to angle of reflection. Are you following me? Look at me then. Then second law will go. Second law of reflection. Second law of reflection. The second law is very simple. We can call it AO is nothing but incident ray. AO we are calling incident ray, OB we are calling reflected ray, and MO we are calling normal drawn at the point of incident ray. See here. Second law says that the incident ray, reflected ray, and normal drawn at the point of incident. How it is? Very simple. Second law says that incident ray, reflected ray, and normal drawn at the point of incident all are lying in same plane. Look at me. This incident ray, reflected ray, and normal drawn at the point of incident all are lying in same plane. See here, how they are? They are lying in the same plane. Lying in the same plane. This is second law of reflection. How it is? Shall I write? The incident ray, the incident ray, the incident ray, incident ray, reflected ray, incident ray, reflected ray, look at me, reflected ray, a reflected ray, and normal drawn at the point of incident, at the point of incident all are lying in same plane. All are lying in same plane. Very simple. Incident ray, reflected ray, and normal drawn at the point of incident all are lying in same plane. These are nothing but laws of reflection. Later on we will see how the light can represent and how the beam of light can be represented, what is mean by mirror, what are types of mirror, that we will explain in detail. Let us see here. Our next concept is ray of light. See here. Next one is how the light ray can be represented, how the beam of light can be represented. See here. Ray of light. Ray of light. See here. Generally, the ray of light can be represented by a straight line with arrow mark. How the ray of light is there? We know that light can travel in straight line path. What we are studying? We are studying in this section mainly rectilinear propagation of the light, straight line propagation of the light. Wherever light moving in a straight line path, what are properties of existed by the light, that we will see in detail. See here. Ray of light can be represented by a straight line with arrow mark. Generally, this line indicates propagation of the light and this arrow mark indicates direction of propagation of the light. The line with arrowhead, that represents ray of light. Then how the beam of light can be represented? See here. Next concept is beam of light. Beam of light. Beam of light. Beam of light means the bundle of ray of light. Number of rays of light, that we are calling beam of light. Bundle of rays of light means how it is? Look at me. If this is one ray of light, this is second ray of light, like this number of ray of light are available. This one. This we are calling beam of light. Simply, what is beam of light? The bundle of rays of light, this we are calling beam of light. Then after this, let us take what is mean by mirror, what are types of mirror, that we'll see in detail, and what are basic terms concerned to optics, basic term concerned to mirror, that we'll see now. See here, our next concept is mirror. Mirror. See here, generally the surface which is responsible for reflection of the light, generally that we are calling mirror. How it is? The surface which is responsible for reflection of the light, that we are calling mirror. I mean, the mirror consists of two surface. One we are calling well polished surface, that we are calling reflecting surface, and second one we are calling silver surface, I mean opaque surface, that we are calling silver surface. See here, how it is? Any mirror consists of two surface. One we are calling well polished surface, which is responsible for reflection of the light, and second surface is opaque, through which ray of light is not passes. See here, how it is? Mirror means the surface which is responsible for reflection of the light. Then we will see how silver surface exists, how reflecting surface can exist. Before that, mirror can classify into two categories. One we are calling plane mirror, and second one we are calling spherical mirror. See here, mirror again can classify into two categories. One we are calling plane mirror, and second one we are calling spherical mirror. Two types of mirrors are exist. One we are calling plane mirror, second one we are calling spherical mirror. For our syllabus, so let it the plane mirror, we will discuss only the spherical mirror. Spherical mirror is nothing but spherical reflecting surface. How this is spherical reflecting surface mean? I can call like this. This we are calling spherical reflecting surface. I mean, wherever light is incident on the surface, again light can bounce back in the same area. On the spherical reflecting surface, that we are calling spherical mirror. On this basis, spherical mirror can classify into two categories. One we are calling concave mirror, second one we are calling convex mirror. See here, this spherical reflecting surface can divide. How it can divide? It can divide into two parts. So this side we are calling bulging, this side we are calling depressing. Similarly, this side is bulging and this side is reflecting surface. Now, I said that spherical mirror is nothing but spherical reflecting surface. The spherical mirror again classified into two categories. One we are calling concave spherical mirror and convex spherical mirror. How it is? Look at here. This spherical mirror can divide. How it can divide? So it can divide like this. This one can divide like this. Similarly, I can divide like this also. This surface I can divide. Are you following me? Write down this. Then how it is? This one I can divide. If spherical reflecting surface can divide into two parts, those parts become concave spherical reflecting surface and convex spherical reflecting surface. This one I can call concave spherical reflecting surface, and this I can call convex spherical reflecting surface. I said that any mirror consists of two parts. One we are calling well polished surface, and second one we are calling opaque surface. Opaque means through which a ray of light is not reflected, not refracted. See here, this part I can call, this I can call concave spherical reflecting surface. Shall I draw here? Look at me here. We will see what is meant by concave spherical reflecting surface, how the ray of light incident, how they can be reflected, that we will see now. See here. Generally, now we will see what is meant by concave spherical reflecting surface or concave spherical mirror. Concave spherical mirror, or simply you can call concave mirror. How concave mirror is there? How reapplied incident, how the ray of light can be reflected, and where the ray of light is meets. That we'll see. See here, this part what I can call, this I can call concave spherical reflecting surface. See here, generally how to draw this. This I can call concave spherical reflecting surface. This surface what I can call, this surface nothing but silvered. Whatever I am drawing these lines, this is nothing but silvered surface. Silvered means through which ray of light is not passes. This we are calling opaque surface. This we are calling silver surface. And whatever this part we are calling reflecting surface. Right around this. Now look at me. How to define then concave mirror, concave spherical mirror? How to define? The concave spherical mirror in which the silver surface is bulging, and reflecting surface is depressed one. The mirror in which the reflecting part is depressed, this we are calling depressed part, and outer surface, this we are calling bulging. Simply, the mirror in which the silver surface is bulging and the reflecting surface is depressed one, that we are calling concave spherical mirror. See here, in this concave spherical mirror, how the ray of light incident, how it is reflected back. Look at me. I can take this nothing but one line, like this I will take. Look at here, this is one line. Now let us take the ray of light. How the ray of light incident? See here, this is nothing but one ray of light incident like this. Wherever ray of light incident on this reflecting surface, how it is? It bounce back. It bounce back like this. Are you following this? Let us take one more ray of light. It goes like this. It goes like this, right? And bounce back and meets here again, right? Now let us take one more ray of light. I can take this is one more ray of light. Are you following? One more ray of light. When ray of light is incident, again it bounce back. It bounce back like this. How it reflected? It can reflect it like this. In this direction it goes, right? How the ray of light come? Here ray of light coming like this, like this, like this. After reflection, the ray of light is meeting at this point. I mean, wherever the ray of light is meeting at this point, then this mirror I can call convergent mirror. Convergent mirror means the ray of light which actually meets us after reflection of the light. After reflection of the light, the ray of light meeting at this point. So I will discuss about this point later. Remember simply, wherever light incident and reflected at a point, reflected and meets at a point, so that this concave spherical mirror I can call convergent mirror. What I can call? Convergent mirror. Convergent means after reflection of the light, all the rays of light meeting at this point, this I can call convergent point. So this concave spherical mirror or simply concave mirror I can call convergent mirror, because it is responsible for convergent of ray of light after reflection. Now this part I am discussing. This part I can call convex spherical mirror or simply convex mirror. How it is? Convex mirror. Look at me. See here. Later we will see what is meant by convex mirror. See here. Shall I remove this? I can draw here only. Convex mirror, or can call convex spherical mirror. Convex mirror. Look at this part. This part I can call convex mirror. How it is? See here. This part I can call convex mirror. Here this part I can call silvered. This part I can call silvered, and this part I can call reflecting. I mean, convex spherical mirror, the mirror in which reflecting part is bulging. Reflecting part is bulging and silver surface is depressed. Just reverse of this. What is convex spherical mirror here? The mirror in which reflecting surface is bulging and silver surface is depressed. Right? This we are calling concave convex spherical mirror. On convex spherical mirror, how the ray of light incident and how they can be reflected. Look at here. Now this one I can call ray of light. This ray of light incident here, and after incident, how the ray of light can reflected. This ray of light can reflect like this. Right around this. Let us take one more ray of light. I can take this point, line I can take. See here, when ray of light is incident at this point, and again it bounces back. Let us take one more ray of light. This is one more ray of light. Incident at this point, and how it is reflected? It can reflect like this. Are you following me? Then, actually after incident the ray of light is divergent here. How it is? This ray of light incident, it reflected back like this. This ray of light incident and bounce back. This ray of light incident and bounce back. Right or wrong? Are you following me this? Then, after reflection, all the ray of light divergent here. How to make convergent? See here. If I produce all the reflected ray in backward direction, look at me. Actually, along this ray of light is not reflected. It is passing. I will discuss this. Why it is passing? Look at me. Now, after reflection, see here. How to say after reflection this ray of light? How it is? After reflection, this ray of light is, it can meet here. If I produce here, this can meet here. If it comes meet here, then after reflection, the ray of light appeared to be meet at this point. At this point, what happened? The ray of light actually meets. But if reflected ray I can produce in backward direction, all reflected appear to be meet at this point. Actually, here all the ray of light appear to be meet, but here all the ray of light just appear to be meet. Just appear to be meet. Then this mirror, convex mirror, responsible for divergent of ray of light. So that this mirror I can call a divergent mirror. Convex mirror or convex spherical mirror simply responsible for divergent of the ray of light. So this mirror I can call divergent mirror. See here. This I can call convergent mirror. Convergent mirror. And this mirror I can call divergent mirror. Divergent mirror. Divergent mirror. Simply, these are types of spherical mirror. One we are calling spherical mirror. Again, spherical mirror can classify into two categories. One we are calling concave spherical mirror and convex spherical mirror. After this, now we will discuss what is mean by image and what are types of image. That we'll see. See here. Our next point is image. See here. Image. Look at me. See here. Now our concept is image. Image. To understand the concept of image, now simply I will take a concave mirror and convex mirror. How reflection of the light takes place. After reflection, how the ray of light can be meeting. See here. Generally, what is image? We can see our image on the mirror, right? On the concave mirror, we will see our the image. Actually, concept of image, how it appear. See here. Look at me. To understand this, again, we will take concave mirror. See here. Concave mirror mean I can take the spherical mirror. The spherical mirror in which the diffraced part is silvered. Diffraced part is silvered. This surface I can call silvered surface, through which the ray of light is not passes. And the bulging part is silvered and depressed part, this we are calling reflecting one. Now I can take, this is the line. I will discuss about this line later. Remember this. This is one line, parallel line, which is passing from center of the mirror. Let us take, this is nothing but one parallel line, this parallel line passing from center of the mirror. Are you following me? Now let us take ray of light incident and reflected back. How it is? Look at me. This is nothing but one ray of light. This ray of light incident here. After incident, the ray of light can be reflected back in this direction. Ray of light incident in this direction. After incident, it bounce back. Or let us take, it bounce back like this. Let us take one more ray of light. It incident here. Incident here. Then after incident, how this ray of light can goes? This ray of light can goes like this. Like this it can goes. right? If the ray of light starting from a point, after reflection the ray of light meet at a second point. The ray of light starting from a point, from this point the ray of light is starting. Look at me, this is nothing but source of light I can call. This we are calling source of light. From the source of light, from this point the ray of light incident, and after reflection the ray of light meeting at this point. After reflection, if bundle of rays of light meet at a point, that point is nothing but image of the object. Where is the object available now? This is nothing but object. From this object, let us take number of rays of light can goes after incident, reflected back, and all rays are meeting at this point. Now this point I can call image of the object. What I can call image of the object. See here. To understand image, what to do here? Look at here. Now I can take this nothing but simple. I can take this is the mirror. Simple. This case I can take again. Look at me. See here. This is mirror. Now this line I can call right or wrong. Let us take any one object available. Let us call this nothing but one object I can call. Say this object I can call AB. This I can call AB. Right or wrong this. Now this ray applied incident at this point. Right. It reflected back. Let us take one more ray applied incident like this. After incident, how it comes? It comes like this. Are you following this? Now after reflection, where the ray applied is meeting? After reflection, ray applied is meeting at this point. Now this point I can call image of the object. I can call this point is nothing but A dash B dash. After reflection, where the ray applied is coming? After reflection, ray applied meeting at this point. This point I can call image of the object. Image mean what? Image mean after reflection, if the rays applied meeting at some other point, that second point is nothing but image of the object. Now this I can call in case of concave mirror. In concave mirror, how it is? In concave mirror, the ray of light actually appear to be meet at this point. I mean convergent at a point. Now let us take in case of convex mirror. Look at me. In case of convex mirror, how to take this? Look at me. In case of concave mirror, I will take how image can appear. See here. Now I can take this nothing but convex mirror. This I can call silver surface. This I can call reflecting. Let us take it as simply line. Are you following? We know that the ray of light incident at this point, it bounce back, right? And the ray of light is passing. Let us take this ray of light is passing. I will discuss why the ray of light is passing here later on. Let us take one more ray of light incident here and get reflected back. Actually, after incident, the ray of light they bounce back and they get diverged. Then if I produce the all reflected rays, how it is? If I produce all reflected rays, they meet here. If I produce all reflected rays, they can meet here. After reflection, the ray of light appeared to be meet at this point. This point what I can call? This point I can call image of the object. What is image? After reflection, if all the rays of light meeting at some other point, that point you can call image of the object. See here. Here all the rays of light appeared to be meet exactly at this point. At this point the ray of light appeared to be meet. On this basis, image can classify into two categories. One we are calling real image, second one we are calling virtual image. See here. What are types of image? One we are calling real image. Second one I can call virtual image. See here. The meaning of real image and virtual image is very simple. Real image means the image which appeared at in front of mirror. In front of mirror, all the rays of light meeting. This we are calling real image. Real image means the image which appeared in front of the mirror, that we are calling real image. In this case, wherever all ray of light meeting at this point, then this I can call image of the object. Wherever object is available, I don't know. Right? Here image appeared here, then I can call this nothing but image. because the reapplied meeting exactly at a point. But look at me, in this case, the reapplied appeared to be meet at some other point. So, where the image appeared behind the mirror. What is virtual mirror? What is virtual image? The image which which backside of the image, or the image which appeared back front of the mirror, that we are calling virtual image. I mean, simply the image which appeared behind the mirror, that we are calling virtual image, and the image which appeared in front of the mirror, that we are calling real image. Then further basic terms are available. What are basic terms in optics and what are sign convention concerned optics, that we will study in the next session. Thank you, students.